Just now seeing this. Ah, numbers. Yeah. Okay. Let me rewind. I need a rewind for my boy. Want to know why binary is important? Want to know? All right. Let me rewind. Because beeps and boops. Yes. Okay. So let's start with this. So, what's 1 times 2? 3. Yes. No, fool. It's 2. All right. 2 times 2. No, obviously 4. We'll just move this along. All right. 4 times 2. 8. 8 times 2. 16. Times 2. 32. Times 2. 64. Times 2. 128. Hold on. Let me just move this over. And we will put this in its own little thing because we are only concerned with these numbers right here. As an IT, you only learn how to count up to 255. So, the reason why this is important... hold on, let me... Okay, let's move this down here. Alright. So, are you down to understand what you, like, something about your computer? Or learn something... You want to learn something new about your computer? Yeah. Okay. Alright. So, if you look at the bottom left corner of your screen, you see that magnifying glass? Click it. Type in CMD, as in Charlie, Mike, Delta. So you open up the command prompt, right? Are you there? Let me know when you're there. Class is in session. Oh, you know about it? Yeah. Alright. So, I'm gonna want you to type this in. And then there's a space right here, so... Slash... Oh. Let me know when you type that in, and a bunch of stuff just gets thrown at you in command prompt. Have you seen this before? Done. Words and numbers for days. Yes. Okay. So, somewhere on there, on your main network, whichever that you are using, I wish I could show you mine, but I don't know if I'm going to be doxing myself. But anyway, so if you look somewhere in there, there's this thing that says IPv4 address. And then it'll spit at you some your IP address pretty much. And then it says preferred in parentheses. Let me know if you see that. So there's like connect specific DNS suffix, description, physical address, DHCP enabled, yes. Auto configuration enabled, yes. IPv6. You found it? Cool. Alright. So IPv4 address, and then whatever that IP address is, we call it an octet. So there's gonna be 4 octets, and then parentheses, preferred parentheses, right? underneath that, do you see subnet mask? And it should be something like 255.255.255. Whatever number. Yeah. Okay. Alright. So, remember, I've said that us ITs only know how to count to 255. So what is 255? So like, okay, let's go back to our little binary chart here, right? So if I say, give me 10 in binary, what is it? It's like, bop, bop, the rest of it's 0. Right? Because 8 plus 2 is 10. Right? Now if, like, let's say... Give me 31. What is that? What is that in binary? 31. This one's gonna be all you. Hold on, let me see. So, what I'm seeing is bop, 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 bop. Did I get that right? No? Yeah. You're like... Yeah, the 16 too. Yeah. I was about to say, you missed it by 1. Right, cool. Alright? So... That's how binary works. You just add these numbers together, and that, you know, that's how you get it in decimal. Yeah. Okay, so the reason why 255 is important, and if you haven't like keyed in on it yet, so 31, I gave you 31, and it was just simply doing this, right? It's just the number before 32. Right? So 255 is just flipping all the switches on. Right? So, let's say I have an IP address of 192.168.198.254. Let's just say. And your subnet mask is 255. 255.0. So your subnet mask tells me what your what network your computer is on, right? So essentially what this is telling me is that 1, 2, 3, 4, 5, 6, 7, 8 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then a bunch of zeros. Alright, so your network is right there. So that's what your subnet mask tells me. Is that your network is that's what network your computer is on. dot 0. Right? So, it's going to be a rare occasion, rare occurrence. But let's say you're on your business computer, right? And hold on, I need to calculate this real quick. So, like, let's say your network or your subnet mask is, it says instead of a 0, it is 224. At least I think so. Yeah, 224. Yeah. So, really quick, give me 224 in binary. This one is gonna be all you, dude. I'm trying to remember how... Yep. That is correct. So, what that means is going back to that. So we got like a bunch of ones and all that stuff, right? So it's saying... that it's saying that your network is now here. Make sense? There's also another way to annotate what how large your network is, using what they call CIDR notation. CIDR notation, and I forget what it's. Yeah, and the zero's a cutoff. Yes. So what that tells me is that these are hosts. This is network. So hosts is us. So that's what how many IP addresses are available to us on this particular network. You following? Yeah. So, CIDR notation for... Let's just go back to something easy. CIDR notation. This equals /24. Because what's 8 times 3? 24. Right? Because we got like a bunch of... like 8 ones. So if we were to annotate this without using like that whole subnet mask doohickey, we just call it /24. So, how am I gonna do this? calculator. Let's see. Yeah. So like, let's say our network now is /20. What does our subnet mask look like now? And then remember. Let me just do this in 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot. So that's 16, 17, 18, 19, 20. 1, 2, 3, 4 dot. Right? So, oh, actually. So now, what did our network side, what happened to our network side versus our host side from where it was before? Our network IPs went down, our host's IPs went up. Because now we have this many hosts, and that's our network. Yep. 255.255.240.0. Yes. Yeah, now you're in IT. I love networking. So, yeah. I'm trying to remember how to... Like, if I were to give you an IP address to, like, you tell me what network we're on, and I'm trying to forget how to pitch that in a way that makes sense. Hold on. Let's go on a little journey, shall we? Addresses for this host. Addresses. What was it? Let's flip over to I'm trying to figure out how to do this without doxing myself. um, that one. I'm trying to figure out where that one setting is where I can see. Oh, studio mode. Oh, yeah. All right. So there's that. Let's see what this guy got. No way. Really?
Hello, everyone, and welcome back to this.
Oppa Gangnam Style? The dude opens his class with Oppa Gangnam Style?
We will address, or we will view the 3 different types of addresses that we find in any IPv4 network. The topics for this mini lecture include the address types in any IPv4.
Oh, you know what? Screw this guy. Let's go to Professor Messer. He's great.
If you've been trying to wrap your mind around the idea of performing the subnet masking using an IP address and a subnet mask, you may be saying to yourself, why are we going through this entire process? Why do we have to subnet the network into all of these tiny different IP subnets? Part of the problem is that we can't connect the entire world directly to each other. There's just not enough resources and bandwidth available to do that. Only one device can talk to another device at a time, and we don't have enough technology to be able to connect together billions of devices so that they were all on the same local network. Having these separate subnets also provides some segmentation and perhaps the ability to add additional security. We could add a firewall and segment out a particular IP subnet that had servers, and that might have a different security posture than an IP subnet that had workstations or printers on it.
So, going back to what I said about like CIDR notation, so what network is this on? And these all have /24s. Yep. So, now that you figured out the subnet mask, what network is this on? So what we're looking at is just the first 3 octets in /24. So the network for this server is 10.1.1.0. Oh, well, I thought this was the address of the server. Normally, you wouldn't give a host a .0 because a .0 or .192 or .224 or a .240 tells you what network it's on. So this is in the network of 10.1.1.0. This one's on the network of 10.1.2.0, and so on and so forth. But anyway, I digress.
That had workstations or printers on it.
Let me see if he... Oh, here we go.
As we saw in some of our
skip right to...
Class A subnet mask, perfect for our...
Oh, yeah. This is the other thing, too. So, this is how you can tell, like, what Class A subnet... or what Class A an IP address is, just based off of the subnet mask. So, looking at the subnet mask, of 255.255.255.0, I know that is a class Charlie. So class alpha only looks at the first 8. So that this whole section right here is class alpha. And then if it expands to 2 octets, that's class Bravo. And then 3 is class Charlie. I don't know if there is even a class Delta, because at that point you have no IP addresses to give out in a
Class A
network
subnet mask
like that.
and customize it so it would be perfect for our network. We'll start with the network 10.0.0.0. Its traditional Class A subnet mask is 255.0.0.0. You'll sometimes see this even referred to as classful addressing because it's based on that Class A subnet mask. If we were to write out the subnet mask in binary, you would have 8 ones at the beginning and all zeros after that. In decimal, the subnet mask then obviously is
Ta-da!
255.0.0.0 or a /8 subnet mask. Based on the subnet mask, then we have 8 bits that are dedicated as the network address and 24 bits that are dedicated as the host address. But it would be very unusual to have millions of hosts on a single subnet. Instead, let's borrow some of those bits to be able to make the number of networks larger and perhaps the number of hosts on a network a little bit smaller. So instead of applying all 24 of these bits, let's back out a few of those and leave 8 bits at the end. If we do that, then we have a network that is still 8 bits long. We've borrowed 16 of those bits that were left in the host part of the address, and we'll use those for different subnets. And then we have 8 bits left over for the host that we would use on each one of those subnets. Since we've moved the bar a bit and added in additional networks, our subnet mask has changed to 255.255.255.0 or /24 network.
Pop quiz. How many host IP addresses are available? Just based off of the information you know already. None? No. So you can't change anything on this side of the network, but you can change anything here. So this is like your IP address. So like I might have .15, you might have .168. You would have 250, no, actually technically 253 IP addresses available because you're not counting the network ID or IP and a what they call as a broadcast, which is another 255. But yeah, so it's like you get your max amount minus 2. That is the available host IP addresses.
Since we're not using the traditional class-based subnetting and instead are using our own subnet that we're defining, we refer to this as classless addressing.
Yeah.
Since we know how many bits are part of the network side of the IP
So it ain't
address,
void. Nah,
how many
it's
bits
not.
are part of the host side, we can very quickly calculate the total number of subnets available and the total number of hosts available by using powers of 2. We wrote a chart like this in an earlier video where we took 2 to the first power, 2 to the second power, 2 to the third power, all the way through 2 to the 8th power. And of course, you could continue this all the way through 2 to the 16th and even further out. You would, of course, start with 2 to the first power, which is a 2. You would double that to 4.
Actually, I think more accurately, you would start at a 2 to the 0, and then if you know what 2 to the 0 is, it's just 1.
Double it to 8, double it to 16, and so on. So you could create a very easy reference chart to use when you're trying to perform some of these subnetting tasks. To use this chart, we would look at the number of subnet bits that we've borrowed and perform 2 to that value to determine the total number of subnets that might be available to us. Then to determine the number of hosts available per subnet, we would use 2 to the host bits power and then subtract 2 from that. One of those will be the subnet address and the other will be the broadcast address.
Oh, a light bulb just went off. Okay, all right. I just kind of remembered how to do the thing. So I was hoping he would bring a memory back into my brain noggin. Okay, all right. Okay. All right. I think I know how I can pitch this. All right, cool. All right. I'm excited. Okay, just do this. Just... Right. Okay. So we're going back to the /24, right? My brain noggin. All right. We know /24 is up until here, so our network is 192.168.198.0. That is our network, right? Because 255, 255, 255, 0. Okay. So back to what he said about subnet bits. So let's go to the example of that. Right? So what is 192.168.198 in binary really quick? Give me that in binary. Bop. I'm like slow. Oh. You can cheat too. You can use a calculator. 128. 64. Bop. Oh, and then that's it. 0, 0, 0, 0, 0, 0. So this is just 1, 0, 0, and 6, 0, 6 dot. Okay. 1, 6, 8, 1, 2, 8. Equals 40. So that's 1. If you can get it quicker than me, I'll come in behind you and check your work. So that would be a 1. And right, because 128 plus 32, we get 160 plus 8. 1, 0, 1, 0, 1, 0, 0, 0. Dot. And actually, that stays. Bop. And 6. So bop, bop. Right? Zero, 1, 1, 0. Bop. But since we have a slash. Let me see. Yeah, you got it, my boy. All right. Since we that's up until /24, right? But what we're looking for is /26. So we have to go a little bit further. We're not quite done yet. And what the we figured out that /26 is just bot, right? Because 24 minus or 26 minus 24 is 2, right? 1, 2. 1 and a 2. And the rest of it is just blah, 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 right? So we have potentially a network of 1, 1. Okay, yeah. Oh, man. This is where we have to think backwards. And this part of buying or of subnet masking is where it hurts my head. Then let me just, because I'm pretty sure you can't see that. So this is where the subnet masking part gets like confusing, or where it hurts my head. Because shit. Because now you got to start thinking the other way around. So we know our network bits are up until here. So you potentially could have a network of dot, or here, .00, because that's as far as our network, right? We could have a potential network of .10. We could also have a potential network of .11. Am I missing one more? I feel like I'm missing one more. Oh, actually, yeah. And .01. I think, yeah. Let me put on some music because it's a little quiet. And let's go back to my library. Listen to some Gura. Actually, listen to Iron Mouse and Neanners. All right. So, once again, we have a potential network of dot 00 dot 01 dot 10 and dot 11. So how do we figure out what network this IP address is on? So we gotta figure out first off, we gotta figure out what network this is. So based off of what you know, what is this in decimal? It's easy. This one's easy. Just 0, right? This is network dot 0. Yeah. So now, what is this in decimal? Give me that in decimal really quick. Oh. Before I go any further, this is like 0, 0, 0, 0. 0, 0. And so on. You had it right the first time, it's 64. Because this is in the 64 position. Oh, you know what? Actually, more accurately, it's like something like that. If that makes sense. That should make sense. Because now you know how many networks you have. Because... right? So we know this is dot 0. This is dot 64 as you said, right? Now what's this one? The third one. Give me this one. Yeah, there we go. 128 and 192. Right, cool. So now, oh shit. So what network is this boy on? Let's put it that way now. So now that we have these IP addresses for our networks, what network is 254 on? 254 Doko. The way how you can tell what network that is on is cause why is that on that layer? .254 is above 192. So whoever this is in this network. Oh shit. So if our subnet mask is slash 26 and I give you an IP address of let's do what network is this one on? It would be on... No. Yeah, well, yeah. You kind of got it right, yeah. But we're looking at... The network will be on this right here. You're kind of right, yes. Yeah. So if I gave you a... If I gave you... $39. Yeah, you gotta look at it as decimal, yes. So what network would our boy .39 be at? What network?
Trust me the least. Pressure not even do that. Precious moments in the battle doubt it. Rest of them will scream shout it. The best don't sleep, I was all about it. But reaping keeps tucked in shadows. This creeping feeling of identity battles. Closing in on every side of me. Red tomorrow.
What network? What network is our boy .39 in? So the way to look at it is from between 0 and .63, between 64 and .187, between 128 and 191. Oh. Wasn't letting you type. Yeah, 0. Yeah. Now you know how to like read CIDR notation, what IP addresses are, well, what network and IP address is on, etc., etc., etc. Yay! So yeah, that is subnet masking in a nutshell. So let's say a network. Go. Just erase some of this. Let's do like one more example to hit it home. Let's do something weird. This might hurt a lot. Let's say our IP address. Okay. What the heck? Weird. Is now. Let's do. Slash. Do /11. Yeah, let's do /11. Let's do, what is it in binary? What is it in decimal? How many networks do we have? Or subnet works, yeah. How many subnet networks do we have? It'll be like so we have upwards to 8 networks. Right, and what networks would they be? Here, yeah. Give me just the decimal parts. That's gonna be a lot, kind of. At least it's not 128. Wait, where are you getting 0000? Oh, I see what you mean. Yeah, okay, I got you. Never mind. Go on. Yeah. Mixed it up. Wow. Where am I at? Hold on. read it again. Na, 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 ah. Na, na, na. Yeah, and then 22 is pop. Zero, 1, 1. Yeah, there we go. Yeah, you're right. I was like, wait, yeah. 0, 1, 1, 0, 0, 0, 1, 0. Yeah. Okay. And it goes up here. And this goes down here. Right, and then yeah, our network IPs would be
We'd run right through those nights. I'll never find my way back to you inside this labyrinth of lights. There was madness in the meaning, never laugh less.
0,
Screaming at the top of our lungs to the numbness. This
0,
city
0,
never died.
or
Those heights.
0,
Find another chance to say thanks for saving my life. I was hopeless. It was stinging.
Yep.
Running roadless. We were singing at the top of our lungs to the numbness. This city never died. What was the root of it all? I couldn't say. Used to jump in that fall, rugged and cliched. Would shrug it off without complaint, not a sound. I used to try to find friends, cause in the end nobody sticks around. It's when you shoved yourself into a crowded place that you turned around and found yourself in love in outer space. Cue the reckless nights, no strings, laughing at our own dreams. Just what the hell was so funny? Bark up the wrong tree, stumble, used to fall in great heights. Amidst a concrete jungle, singing cause it felt right. We mixed the ennui and troubles, rhyming our discontent. To know its history, I can't forget the time that we spent. Convinced that this could mean another end exists between real and pretend. Twisted all to fiction where I missed my chance to not ascend and disappearing into the mist. It never
Yeah.
happened, is the me that I can never befriend. I let it
that, right? So we have
fade in, fade out. This race
8.
we dream without a direction, floating aimlessly. There's nothing left back there.
Which equals
Breathe in, but it won't stop.
dot 0,
Boring
dot 32.
find a way back to you inside this labyrinth of life. Madness in the meaning, never laugh less. We were screaming at the top of our lungs to the numbness. This city never died. Was there ever a soul inside? Chasing fireflies between the soaring high rises, left a trail behind to find a wasted time of our lives. Silent singer, overworked and underpaid. Inks and opposites, a coffin until office where you're laid. Yet a thought persistent optimist who ought to be afraid. Saw the nothing wrong in writing songs behind a lonely shade. Is the world a sadder place without the words that you conveyed? When the ladder fell and shattered every bar that we had played. Does it matter in the end? The sound diminished and decayed. And your friends grew tired of fantasy. You're wishing they had stayed. You don't get to say I miss you. You watch your heroes fade into the rear view mirror of the villain you portrayed. Stop the pity party. Listen, you don't get to be dismayed. You don't get to be emotional. You're blessed you got it made. These the best of years of life because you chose to make a trade. Recollect the days you hoped and you prayed for this. What is there to miss?
How's it looking over there? Well, actually, let me hit the head really quick. I'll be right back.
Waking up now to my real life. Let me daydream till the next flight. Drowning so long, I got older. Now the crowd's gone. Is it over? Is it over?
And I'm back. How's it going over there? We're looking for each one. For which one? For it to be on. So, da da da. What's the question? Oh, actually. Yeah, you're right. Yeah. You're right. I was like, yeah, you're right. Yeah. So it'd be on the 16.0 network. Yeah. I was like, oh yeah, we're not looking at the last octet. We're looking at the whatchamacallit. That one. The second octet, yeah. That being said, let's see. Oh, that question sounds so messy when I think about it. I was about to ask how many host IP addresses are available but we can just do it on one network. So let's say on... Oh, shit. Wait, where'd it go? Clear it. Delete it entirely. Okay. So, on network 6.0.0.0. How many host IP addresses are there? So now you're gonna have to go beyond 128. And you think I'm joking? But they actually do ask these questions on your exams. So this is where it gets a little messy. Wait, how many are there? Yes, hold on. Okay. How big is that? You can probably guess where I'm going with this too. Cause... Oh shit. Is there a carrot? Shit. Hold on. I need to figure out a better way to do this. Dear Lord. I'd hate for you to bust out like... I'm gonna do this. Never mind. It's huge. Never mind. I was gonna ask you how many host IPs there are on this network, but holy crap, that's ridiculous. It's huge. I mean, you could. You just gotta think the other way around. So we're looking at 2 to the 20th. If you can figure that out, -2. available host IP addresses. Or you know what, you could do this for like a so yeah. It's huge. But anyway, that's networking in a nutshell. As for why you would want to subnet mask, like in a ridiculous thing, why not just go like dot or /8/16/24 and call it a day? So this is why, I don't know if you've heard recently, but we're getting to a point where we're running out of IP addresses in the whole world. And so like, I think Google is in charge of that, I think, /8. I think. Something along the lines of that. So Google is in charge of everything before here. That's all theirs. Actually, technically, it would be... This would be Google, I think. So we're getting to the point where like we're starting to run out of IPv4 IP addresses, and which is ridiculous because like as you saw, 2 to the 20th is ridiculous, but that is putting into account of like everybody has their own IP address and etc., right? So the reason why you would want a subnet mask is to somehow make your network bigger. Something along the lines of that, and yeah. So because we are running out of IP addresses and all that stuff, going back to ipconfig/all from like earlier on, you type in cmd, pull up the command prompt, type in ipconfig/all again, right? You go there, you will also see IPv6. So we're starting to implement IPv6 IP addresses on top of our IPv4 addresses. So although finite, our IP address availability has gotten so much bigger. So yeah, yeah, to like mitigate the whole IP address issue that we're having lately. Yeah. And I think like Comcast is .10 or 10.0 or something like that. 10. Whatever is Comcast. What was it when I was in Virginia? So like Cox is 192, I think. Yeah, so they have like a relatively classful IP address. Yeah. But anyway, that is subnet masking in a nutshell. And like I said too, they actually do ask these questions on your certification board of sorts. So like they go like, yeah, so what's the network? What's the so they give you an IP address / CIDR notation, and then what network is it on, or something like that, something along the lines of that. And then yeah, binary is no joke. Oh, I could also show you hexadecimal if you're down. Are you down to learn hexadecimal? Sure. Okay. All right. So going back to how, like, let's get rid of all this. Let's start a new doohickey. So if you remember our little whatchamacallit, our chart, right? So 2, 4, 8. Let's build it up again. 32. 64. 1, 2, 8. So essentially what this is just 2 to the 0 power, 2 to the 1, 2 to the 2, 2 to the 3, etc., right? Hexadecimal. It's literally that. It's like 16 to the 0, 16 to the 1. And that's as far as we go. That's as far as we go in hexadecimal. Why that's important. The reason why I write it down over and over again is so I remember it. The reason why that's important see where I'm going with this? So let's go. Oh, actually, first let me show you something. The way the numbering system for hexadecimal, or hex for short. So we all know our decimal system. We go 5, 6, 7, 8, 9. What do you think goes beyond 9? Actually, push this over. Ah. Can't forget 0. Never forget 0. Right? So, let's put this as a little note in the corner somewhere. Bringing these bad boys back. So let's go. Let's go with. Two. If I say what is 13 in binary, or give me 13 in base 16 and in binary, or hexadecimal and binary. So we know. What was it? Did I say 13 or 16? I forget. 13. Let's just go with 13. So bop bop 13. And then as for base 16, go 13. Base 16 is just D. Get the D. Right? So, there's like a step in between. I'm forgetting to make this make sense. Because essentially you're just splitting this in half. And then this is another 1, 2, 4, 8 of sorts. So let's say what is 255 in binary and in hexadecimal, right? So we all know. But what is that in hexadecimal? That is gonna be FF. I think. Reason being, going back to Shoot. Give me a moment. I'm trying to figure out how to like make this make sense. I think. Oh, okay. All right, all right. All right, I'm back. My dad made Filipino styled muffins and it was so good. Yeah. So, did we figure out what 170 is in binary? What do you know? 1. And we know this is a 0. 1 0 1 0 1 0 1 0. All right. Okay. So, see where I'm going with this? Eight plus 2. This one's actually a trick question. What's 8 plus 2? Ten. You're wrong. The answer is A. So, now what is it? Ah. Hexadecimal, yay! So the reason why this is important. So if you look in, like, let's say, let's go to... Wait, I wonder if Paint has it. Let me just see real quick. Or you know what? Let me see if there's a thing on, like, let's say Google. Colors and X. All right, so here's how it's gonna go down. The reason why that's important, you go to that website. I don't know if you can see it. Can you see htmlcolorcodes.com? Yeah? Okay. So if you go to that website, just scroll down a bit. You'll see like a number and then like a 6-digit number of sorts, right? Let's see, what if that is... Let me know when you are there. Yeah, 00000 is the best. And yeah, so hexadecimal is like every 2 numbers that you see there. The first 2 numbers on the number thingy controls your red. The next 2 controls your green. And then the next 2 controls your blue. And that's how computers read. Although it's compressed, that's how a computer reads RGB. Yeah. That's how computers read colors. That's how they make images. So there you got like something in binary telling the computer at this point drop a pixel with this color, and then so on and so forth, and that's how you get images. The other thing, so I know if you haven't closed command prompt yet, take a look at it again. But if you did close it, we're going back to it. So ipconfig/all again, right? The reason why that's important for us when it comes to networks also. Let me know when you got your ipconfig/all up. There is one really nifty thing that I want to show you. And this one you might want to keep guarded. Did the dude? Okay, cool. Do you remember where it says IPv4 address? In that section, maybe like the third line down, there is a thing that says physical address, right? Yes, let me know if you see it. Don't tell me what it is, because that gives away, like, you. Along with your IP address. So, that is a network card's, like, fingerprint, pretty much. There is probably 1 in, like, a million or so that has the same IP address. Or not IP address. This is called a MAC address. Media, what was it called again? It is a media access control address. Yeah. So that tells the network specifically who with this IP address the network packets need to go. So like let's say I'm sending a message from me to you that says hello. If we happen to both have the same IP address, that's how the packets can tell who it goes to, because our MAC addresses are different. Right? The thing, I forget what it's called. MAC address. Hold on. I'm trying to remember what it's called. MAC address vendor lookup, I think. It's called. Let me do something on the side here really quick. Okay, whatever. So the first 3 sets, there's 6 of them, right? The first 3 sets, so for every manufacturer, they have, you can tell what the piece of equipment is just based off of the first 3 MAC address thingies. I forget what you call them, and it's like bugging the heck out of me. I don't want to call it octets. Well, they kind of are. I forget what you call them. But yeah, long story short, you can tell what kind of device is hooked up to your network just based off of those first 3 doohickeys. So like it'll like go down really specific to like an HP printer or something like that. It can get like super like granular like that, and it's kind of cool and also kind of scary when you like know things like that. So like if you look at the network and you like notice some kind of device that is not on your that's not supposed to be on your network is on your network, you'll be like, what the heck is that? You look at the MAC address and let's say somebody's hacking your network with like maybe an Asus laptop of sorts. So you know, based off of like the MAC address, that is a laptop that shouldn't be there. And then you can also you can infer also like what network is on, and then you can tell where in the building they are just based off of that. It's kind of cool. I like it. So like it got I've seen yeah, something along the lines of that. Like you have like a bunch of applications that help you with maintaining your network and like security stuff. So like I forget what it's called. But yeah, so like let's say somebody plugged in their printer onto the network, and actually what would happen is it would kill that port because I have port security. So I'm gonna put this. So like I can see which computers are on, what ports they are on the switch, and then whether they're whatchamacallit, like up to date on like antivirus or something like that, or on like Windows updates or something. And that was like my job in the Navy, is to figure that out. It's like this computer didn't get the latest and greatest antivirus definition, so I have to update that computer. I can like remote into it, kick the guy off, like whoever's on it, I can kick them off. It's kind of a dick move, but yeah, like it's funny. I can kick them off and then like update the computer from my workstation. It's funny. I did it once too, because like I have an ET friend that is like downstairs. No, like maybe a couple of rooms over on the ship. And I know he's not up to anything because I can see like he's just on Facebook from my computer. And then I was like, all right, that computer's out of date on antivirus. So what I did is I remote into there, and when I do, it locks out the computer, but it also says your computer is locked, and then it'll show my name, sort of like admin like Daruka. Admin, it's locked out by admin.daruka, right? And then it would call radio and go like, Daruka, did you just like kick me out of my, or lock me out of my computer? It's like, yeah, your computer's out of date on antivirus. Okay. Can I just save something really quick, and then give me 5 minutes, and then you can do your thing. All right. So yeah, like then I jump out of it, let him do his thing. 5 minutes later, I lock him out again, and then I update it. It's cool. Yeah, there's like a lot of handy tools to like keep an eye on your network. I think. Oh yeah. So we get a notification from whatchamacallit, from what they call a CTF 1010, and that is like Big Navy network, right? So they keep an eye on like everybody, or yeah, all of the ships from all over the world, right? And they're saying, hey, a computer on your network is going to this website and it's bad. And we're like, what the heck? Okay. And we have to respond within 24 hours. Even if we don't mitigate the issue, we just let them know. Yeah, we received your message. We're looking into it. And after the 24 hours, you're good. But you still have to mitigate it. So you can't just like let it slide, because they're still keeping an eye on your network, right? So we go get on our our application that goes to like, that can see who is the offender. Lo and behold, oh, we can see who the offender is, or where it came from, who exactly is the offender. So like, we found a computer, we found who logged in at the time when it happened, and we find out that it's a friend of mine. I'm like, oh no. Next thing we know, we call him down, like, we saw you looking at ogre porn. Dude, I was like, no, you can't. Not on a freaking government computer, bro. And he's just like, yeah, I was down bad. I shouldn't have, but yeah, I learned my lesson. So we had to, so the policy is, if like somebody did something bad on the network, we take away their account for like an X amount of months. I forget, like if it was a 1 month or 3 months, I forget. So we lock him out, lock his account out, so he can't log in or anything. If he needs any maintenance done, he has to do it through somebody else, which is a bummer. And he has to do some kind of training also, and then without completing that training, he cannot get back on the network. But so what we did was like, we lock out his account, but he's able to just log in just to go to this website, a specific website, to do his training, and that's it. Anything else, he can't even go to like paint.exe. He can only open up Internet Explorer. Yes, Internet Explorer, not Google Chrome, not Firefox, not Edge. Internet Explorer. And go to this military website thing and do his training, and that's it. He can't even open up any applications to do maintenance. And that's pretty much it. Yeah. And after the 30 days and he completed that training, he can get back on the network. But yeah, ogre porn, dude. I was like, what the shit? Yeah, so I think we were in port when we found it. We were